Here we have water vapor flowing through a pipe through one inlet, and it splits into two equal exits. So we're told a few things at the inlet. So we have 30 meters per second, we have the velocity, the area, pressure, temperature, and then we're told at the exit it's pretty much going to be equal. So you have equal temperature, equal pressure, and then equal velocity and area. So in other words, volumetric flow rate. We're asked to find the mass flow rate at the inlet and at exit 1, or exit 2, I guess you could call it, and exit 3. So this is pretty simple, conservation of mass. So just remember what comes in. So we'll call it whatever, I'll call that inlet actually. So whatever comes in has to be equal to whatever comes out. So all the inlets have to be equal to the exits. So at the inlet you have m dot 1, and that's going to be equal to the sum of the exits, which is going to be m dot 2 plus m dot 3. And then we're going to use the relation of mass flow rate. So m dot, we'll call it 1, is going to be equal to the velocity at 1 times the area at 1, or the volumetric flow rate, divided by the specific volume at 1. So we already have some things at the inlet here. So we have the velocity of 30 meters per second, the area of 0.2 meters cubed, and divide it by the specific volume, which we're going to find. So we're told we have 5 bar 360C. Turn to table A3, go to 5 bar, and you have 151. So we were at, was it 360C? So we're definitely superheated. Turn to table A4, go to 5 bar right over here, and we have 360 and 0.5796. So here's our specific volume, 0.5796. So plug that in here, 0.5796. And if you plug this into a calculator, you'll have 10.35. Do your units out, and you'll come to kilograms per second. So that's your mass flow rate 1, m dot 1. Now we can just use algebra to find the mass flow rate at the exits. So remember that m dot 1 is equal to m dot 2 plus m dot 3. And m dot 2 is going to be equal to the velocity at 2 times the area at 2 divided by the specific volume at 2, which we're told that this numerator is going to be equal at 2 and 3. So we have that's going to be equal to V3A3. And because the specific volume is a function of pressure and temperature, it's also going to be equal. So V2 is going to be equal to V3. And all that this means is that m dot 2 is just equal to m dot 3. So if we set m dot 3 equal to m dot 2 in this formula right over here, you'll have m dot 1 is equal to 2 times m dot 2. Or m dot 2, which is what we're looking for, is equal to m dot 1 divided by 2. And we already have m dot 1, so it's just m dot 2, which is equal to m dot 3, is equal to 10.35 divided by 2, which is equal to 5.175 kilograms per second.